In the space of science and colossal secrets, the subject of what existed beforehand to the enormous blast has sparked mixed discussions and interested characters for a long time. This colossal demand doesn't simply test how we could unravel the universe. It challenges the veritable farthest limits of human knowledge. Envision standing at the edge of existence, investigating the enormous shadowing and considering what lay there before our universe was envisioned. The event of the Big Bang marked the dawn of history, space, and all that we know. At any rate, was there a moment sooner beforehand this might have existed? Could there at some point have been a state of nothingness, a quiet before the grandiose gathering began? And if this is true, was it? Or maybe there was something substantially more disturbing that existed already before time itself. As we delve further into this inquiry, science takes us on an excursion past the universe's starting point into contemplations that challenge our awareness. Physicist Brian Cox, known for his contribution to the wonders of the universe, proposes that something astounding could have existed before the colossal explosion. He urges us to re-examine our thinking of the real world and existence. In this assessment, we'll take apart the science, the hypothesis, and the amazing insider mysteries that may help us understand what existed before all that. We'll explore considerations like godly improvement, quantum changes, dark energy, and even multiverses. The responses we've uncovered may stun you, but they could likewise open new understandings of our situation in the universe. Prepare to jump deep into a world beyond imagination and science, where the dark still winds around the shadows, leaving researchers stunned and, in some cases, even steamed. We should investigate what existed before the Big Bang and why these speculations challenge all that we assumed we knew. To appreciate what might have existed previously the Big Bang, we first need to examine what the Big Bang really was. The Big Bang, as researchers characterize it, refers to the moment when the universe turned out to be incredibly hot and thick, developing quickly to set off the improvement of all matter, energy, and limitless forces. When we look toward the night sky, we see proof of this hot starting with systems fanning out all around from a starting point. Anyway, why did this happen? Besides, was there a time before this thick, hot beginning? As shown by the hypothesis of gigantic extension, there was undoubtedly a formerly, and it was off by a long shot to void or serene. Tremendous development suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a colossal vacuum. At any rate, this vacuum wasn't entirely unfilled. It contained a colossal sum of energy that powered the speedy expansion of room itself. This expansion, called inflation, occurred so quickly that it fundamentally settled the basis for all that would proceed in a piece of an ensuing space. It broadened at incredible rates until the expansion dialed back and the energy changed into issue particles and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it out of nowhere develop the universe? And why did it stop? Experts believe that this limitless extension made patches of the universe, each experiencing its own Big Bang. Envision a fabric broadening unendingly, with tiny air pockets forming here and there, each air pocket representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially boundless Big Bangs and a limitless number of universes. Our own is only one of many. This gigantic, mind-bending reality challenges how we might interpret the very universe itself and leaves us with the question, what else is out there? The thought of nothingness before the Big Bang is speculative, not real. Anyway, per our ongoing seeing, paying little heed to whether you kill all energy particles and radiation from the universe, it would still not be truly void. Our universe is filled up with dark matter, dark energy, quantum fields, and different forces that weave an inescapable woven artwork of something, even in its most empty form. Paying little heed to whether we envision stripping away all of these forces, leaving a dead space, the universe would still create new sorts of energy. This reality alone is puzzling to experts, as it suggests that genuine nothingness may be inconceivable within our boundless appreciation. Space itself has properties, rules, and constants that keep it from being thoroughly unfilled. Envision making a region with literally nothing in it. No particles, no radiation, and no energy, aside from quantum fields and significant constants. These would still exist, proposing that this nothingness has properties. For example, there's a quirk called Z-point energy, which addresses the most inconceivable energy state of quantum fields. In this state, particles can still immediately show up and dissipate, making a creepy reverberation of development, even in what ought to be vacant space. This challenges what we would call a genuine void and suggests that, yes, even before the Big Bang, there was something that researchers are still beginning to understand. Quite possibly of the most surprising hypothesis in current cosmology is the opportunity of immortal development. If inflation could make our universe exist, it's conceivable it could continue forever. Brian Cox describes an incredibly immense inflationary multiverse, where universes are boundlessly made and continue extending. Envision each Big Bang as a streak lighting another universe while inflation goes on in different regions, creating innumerable other universes. This cycle could, in principle, happen forever. This thought of tremendous universes begetting others gives rise to a captivating idea of a fractal universe, where each new universe may, in reality, make its own Big Bang. Each universe exists as a different, autonomous space, unaffected by the others in light of the quick development of space. For scientists, this speculation is both exciting and disturbing, as it suggests a ceaseless multiverse with no authoritative start or end. Envision our universe being only the slightest bit in a monster, inestimable design, always growing and continually making new universes. And imagine a scenario where the upsetting truth is there is no previously or later, but rather an immortal pattern of universes forming and rotting. How we might interpret nothingness changes when we consider quantum field theory. As indicated by this theory, the universe isn't simply a combination of issue floating in space. Maybe it's a complicated organization of energy fields that fill the universe, connecting to make all that we notice. These fields are like imperceptible oceans, with particles acting as waves or disruptions. In any event, when fields are at their most minimal energy level, known as the vacuum state, they are still active. Particles can show up and vanish in these fields immediately, acquiring energy before returning it. This peculiarity brings about virtual particles, substances that immediately exist and then disappear, leaving only a weak memory of their presence. The idea of virtual particles challenges the possibility of a genuine void. Envision an unfilled universe where all matter, radiation, and energy are taken out. Would you have, in fact, nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain dynamic, sometimes creating transient particles. This consistent development in what should be nothing suggests that the universe doesn't perceive our idea of vacancy. The fields and forces persevere, filling the universe with a secret energy that prevents absolute nothingness. This grasping raises a captivating question. If fields create particles and particles create matter, could the universe itself have risen from this nothingness, filled with quantum fields? Dark energy is a strange force that presently drives the accelerated development of our universe. However, did dark energy exist before the Big Bang? From certain points of view, the way that dark energy exists today is an extra of an energy field from before our universe's development. The properties of dark energy seem to suggest a giant hidden force that could have existed in some form before the Big Bang. Some hypotheses suggest that dark energy, in a much stronger state, might have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, whether or not our universe were depleted of all matter and radiation, this force would continue to grow the texture of space-time. This thought prompts a disturbing inquiry. If dark energy was present before the Big Bang, might it at some point have formed the conditions that led to the birth of our universe? Might dark energy be the quiet architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy, not merely as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another hypothesis is that cyclic cosmology offers an alternative to the Big Bang as the ultimate start. It suggests that the universe goes through vast patterns of birth, death, and revival. In this model, the Big Bang is not a one-time event but may be part of an immortal cycle where universes grow, break down, and then recover in another cycle. This hypothesis proposes that our universe could have been renewed from the remnants of a past universe. The course of contraction and development in a cyclic pattern would mean that there was never a real beginning, but rather an eternal series of universes arising, developing, and renewing themselves again and again. Cyclic cosmology raises significant inquiries about time, as it suggests that time itself may be repeating, rather than direct. If this hypothesis is right, it could imply that what existed before the Big Bang was simply another form of the universe, one that fell solely to give birth to our current universe. For scientists, this hypothesis offers a rich reply to the question of extreme beginnings, suggesting that there is no obvious start. The universe has always existed in some form. Rising above our thoughts of time and presence, gravitational waves are another interesting concept that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by the acceleration of massive objects, such as colliding black holes. Some scientists believe that these waves could have originated in the very early stages of the universe, during the Big Bang itself or even before. If this is accurate, it could indicate that there was something that happened before the Big Bang, a disturbance or event that set the stage for the creation of our universe. The prospect of gravitational waves from before the Big Bang presents the possibility of detecting remnants from a time before time itself. Through our journey into the unknown, we find ourselves at the very edge of what is comprehensible. The universe, with all of its complex web of possibilities, continues to stretch beyond our understanding. Was there something before the Big Bang? And if so, what could it have been? As we continue to push the limits of science, we approach a place where mysteries continue to reign supreme. What lies beyond our knowledge may forever remain beyond reach, or maybe one day, we'll uncover that before the Big Bang, the universe was just one stage in an eternal cycle, an unending march of creation and destruction, where time and space, like dark energy, continue on forever. As we dive deeper into these cosmic inquiries, we find that the boundaries between known science and speculative theory often blur. One of the most intriguing aspects of the universe's origins is the role of quantum fluctuations. In the quantum realm, tiny fluctuations in energy can lead to the creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the universe's fabric might have sprung from a quantum vacuum, where particles are continuously being created and annihilated. The idea of a quantum vacuum doesn't imply a complete absence of existence, but rather a state full of potential, where energy is constantly shifting and fluctuating. This aligns with the concept of the universe being born from a quantum fluctuation, possibly driven by quantum fields, which might have existed before the Big Bang, as the initial spark for the creation of spacetime itself. In this scenario, the Big Bang could be seen not as a singular, explosive event, but as the beginning of a new phase in an ever-evolving quantum field. Some theories even suggest that the observable universe, as we know it, could be just one in a series of bubbles or regions within a vast cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang might not have been unique to our universe but part of an ongoing process of bubble creation within a larger multiversal structure. These bubbles might have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the idea that the multiverse may not be entirely inaccessible to us. Some cosmologists believe that the possibility of detecting signatures from other universes exists, albeit indirectly. For instance, they propose that there might be faint traces of collisions or interactions between our universe and neighboring ones. These traces could be imprinted on the cosmic background radiation or even in gravitational waves, as discussed earlier. Detecting such evidence would require advancements in our observational tools and technologies, but the prospect of discovering signals from other universes challenges our perception of the universe's limits. Furthermore, the idea of parallel universes opens up exciting avenues for understanding the nature of reality itself. If multiple universes can exist, each with its own set of physical laws, then the very definition of reality could expand far beyond our current understanding. It may also offer solutions to long-standing mysteries, such as the fine-tuning problem. This problem questions why the constants of nature are perfectly suited for the existence of life. If a multiverse exists with countless universes having different properties, it might simply be a matter of chance that our universe is one that supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another enigma in understanding the true nature of the universe. Dark matter, which makes up a significant portion of the universe's mass, is invisible to our instruments but exerts a gravitational influence on visible matter. Its origin and properties are still largely unknown, but it could be intimately connected to the fundamental forces that shaped the early universe. Some scientists speculate that dark matter might hold the key to understanding the first moments after the Big Bang, as well as providing insights into the very fabric of space-time itself. In the end, as we push the frontiers of cosmological science, we are not only exploring the universe's past but also its future. The quest for understanding the origins of the universe, whether it stems from a quantum fluctuation, a cyclic pattern, or from the mysteries of dark energy, may ultimately provide us with a deeper understanding of the nature of existence itself. This journey into the unknown is a testament to human curiosity and the endless desire to uncover the hidden truths of the cosmos.